Well, good morning, good afternoon, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great webinar on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our speaker, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your questions, and we'll try to get to as many as we can near the end of today's webinar. Also, at the end of today's webinar, we will be doing a drawing for two $50 Amazon gift cards. So please stick around. Hopefully you'll be one of our 2 lucky winners today. Okay, with that, we will go ahead and kick off today's webinar, which is GitOps Best Practices for Continuous Deployment and Progressive Security. Our speaker today is Gadi Naor, who is CTO and co-founder of Alseed. Hi, Gadi, how are you? Great to have you here.
Thank you. I am doing great and really happy to be here.
Excellent, excellent. Well, I'm going to put myself on mute. I know you have a great presentation on tap, so I will put myself on mute, let you get right to it.
Thank you, thank you. Hey everyone, thank you really for joining us in these extraordinary time. My name is Gadi Naor. I'm the CTO and one of the founders of Alseed. To briefly introduce myself, I am from Tel Aviv. 2 months ago, I would say that I would spend half of my time on airplanes and around the globe visiting our customers, but let's call it recent affairs kind of grounded me. I do try to enjoy skateboarding as much as I can, and by way of professional experience, I've spent most of my career on the dark side of the operating system doing kernel development with companies like Checkpoint, Alto Networks, and Juniper Networks, mainly working on security infrastructure like firewalls, IPS systems, VPNs, and at some point I got upgraded to the cloud native world, and when containers kind of emerged, this is when Alseed was kind of born into reality. Definitely one of the hidden things for me is that skateboarding and Kubernetes share those 3 magic characters. And with that in mind, what are we planning for today is mainly talk about the key benefits and principles of GitOps. This is kind of definitely a new way of doing things as far as the cloud native application infrastructure way. There are new challenges with every new method and approach of implementing and building, let's call it stuff. There are new challenges, especially around security, and we will definitely color some of the progressive security mechanisms that GitOps adopters would definitely want to take a look into. So what is really GitOps? So it's not a tool or a software. It's really an operation model that adopts Git as the center of everything. It's the center, or in many ways, oftentimes it's referred as the source of truth. And it's not really technology specific. So while we see GitOps a lot of times described in the context of Kubernetes, serverless and other kind of deployment mechanisms or compute or application vehicles are definitely elements that GitOps can serve them just as good as Kubernetes. And it is pretty much set of principles. So it's pretty much focused on why doing things instead of like how we are implementing those things. And when it comes to those principles, there are 4 main principles around them. The first one, in the spirit of Git and code, the system is described declaratively, and this is something that resonates extremely well with the Kubernetes way of doing things, where everything is declarative and the system is eventually consistent, and pretty much Kubernetes have those control loops that help us to satisfy or reconcile the differences between the desired state and the actual state of the system. So GitOps is definitely something that we describe systems with a declarative manner, and maintaining this description in Git. The canonical, or pretty much the core state of the system, is version, which means that all the beautiful features that Git gives us as developers, like history, like diffing, like branching and merging, and all those workflows are pretty much inherent to the GitOps kind of spirit and way of doing things. And as far as workflows goes, approved changes, which are pretty much changing the desired state of the system, are automatically applied to the target system. So in the case of Kubernetes, we will see software agents that are basically ensuring the application of this new state and the transition of this new state. And those software agents are oftentimes implemented as control loops that pretty much takes care of both ensuring that the desired state of the system is what is reflected in the actual system. So there's a mirroring between what's happening in Git and what's happening inside the, let's call it in this case, in Kubernetes, the state of the cluster. And if there's any drift or divergence from the actual desired state between the desired state in Git and the actual state of the system, the control loop or the software agent will take care of reconciling this state. And there's a great question on whether, and this is mainly for those of you who are considering GitOps as kind of their way of building their cloud native application infrastructure, whether this is something that is right for the team. And when you think about Kubernetes, for example, or GitOps more specifically, these are both practices and technologies that are engineering driven, which means that it's the opposite than IT driven culture. And it really boils down to how the different stakeholders in a company, whether this is a small one or a large one, needs to have a handle on the system. So oftentimes you will see with larger kind of organizations that if security teams, for example, would need to have visibility into this black box or into those workflows, then this is something that creates more challenging as far as implementing or introducing GitOps as an end-to-end practice for building those cloud native applications. And when it comes to even GitOps itself as a concept, there's a huge difference between pushing software to production versus pulling or reconciling kind of the desired state of the system from Git into the target environment itself. And one fundamental change that happens when you move into the GitOps operational model is with the fact that kube control is no longer kind of your go-to deployment mechanism, but actually access to the cluster is equivalent to access or the ability to push things into the Git repo, which from a security standpoint, and we will dive into that a little bit later, has significant implications on some of the trust boundaries and assumptions that we are making on the system. Some of the implementations of GitOps that are out there that are quite well known, Argo is a great example of that. Flux is by Weaveworks, which are, I think, coined the term GitOps. Is another good system that actually now became part of the CNCF. Jenkins X is another good example, and D2IQ has their own kind of flavor based on Argo called Dispatch. So essentially, there are already tools out there that really bring this spirit on and implementing the spirit of GitOps as actual software tools. So when it comes to the benefits that comes with GitOps, one of the main benefits that we can see as far as velocity of engineering teams is the ability to have developers work with their comfort zone of tool stack, which is Git, which means that any developer joining the team can push something to Git, and this is by extension would be reflected into the cluster itself. And the benefits around the audit trail that Git provides, as well as the ability to both have the CI side of the fence, as well as the deployment side of the fence, as well as the release, is something that definitely caters to unify, for those that try to unify the tools that are being used by application builders, and specifically those that leverage declarative mechanisms to implement those cloud native applications. As far as the practices that are really matter is the fact that we can have this Git audit log and history help us audit the changes and triage and track back any changes that were made into the cluster, which means that this is something that we really want to make sure that we cover as far as our practices around GitOps. What about security considerations when it comes to implementing GitOps? So a little bit before we dive into GitOps security considerations, as a quick reminder on kind of what are the building blocks that Kubernetes has as far as trust boundaries and the moving parts. We really need to think about what implications or assumptions that we are making when it comes to operating and shipping application into Kubernetes are changing or breaking or are being enhanced when it comes to implementing GitOps workflows and introducing that as far as our workflows. So we have pretty much three main kind of components when it comes to Kubernetes cluster. We have the control plane, which represents kind of the brain of the cluster. So think about it as like the control tower of whatever application components we are deploying into the cluster. We have the worker nodes that do carry the Kubernetes software, which is kubelet, which is responsible for making sure that pods are being scheduled and running and on the nodes themselves. And then we have the application workloads as part of the application that we use to build on top of the cluster. And it could really be something that leverages namespaces to represent part of the functionality of the application, or it could be a multi-tenant application that leverages multiple namespaces to deploy the very same application. And there are many challenges around the runtime security of workloads themselves inside the cluster. And essentially, we can have application level pods, and we can also have infrastructure components like log monitoring agents, security agents, as well as, for example, agents that make sure that the cluster is deploying from Git, basically implementing the GitOps workflows. And the third component is pretty much external to the cluster in most cases, and represents the software supply chain from which we pull images into the cluster itself. So when we look at all those moving parts, and in Kubernetes we have multiple moving parts, we really need to identify like what are the trust boundaries. When we provide access to a user, for example, what is the blast radius that is associated with that? And Kubernetes natively has all the mechanisms to make sure that we can leverage those. So for example, RBAC, which is notoriously is the subsystem that actually help us control who's allowed to do what. In GitOps, this assumption relatively changes the picture. So let's take a look a little bit about this part. So normally before GitOps, we would leverage kube control to apply or change or make changes to the environment. And when git push becomes the equivalent of kube control apply, this is something that actually breaks a very simple assumption that we had on the Kubernetes cluster. So instead of having, for example, a jump host from which we allow access to the API server itself, all of a sudden anyone who can commit to the Git repo from which the GitOps operator, whether this is Flux or Argo CD, would pull the changes, then this is something that breaks this very assumption on who is allowed to apply changes into the cluster. So again, if we thought about building a perimeter around the Kubernetes cluster and making sure, for example, that the API server is private, all of a sudden anyone who has access to the Git repo actually breaks this assumption. And this is a fundamental change when it comes to implementing GitOps workflow and actually deploying the GitOps operator into the cluster itself. Another aspect that when it comes to the attribution of API operations that are being made on the cluster itself, we can really see that if Kubernetes, for example, would authorize users based on their credential through the mechanisms of authentication, which helps us to establish the identity of the user, and then authorization based on RBAC. With GitOps, this basic assumption breaks because as a developer, I'm pushing into my Git repo, and then this change again propagates into the cluster, and the application of this change is made by something that applies all the changes to the system for multiple users. So again, the user attribution was kind of offloaded from Kubernetes API server to the Git audit log, which is a different way from security standpoint to monitor, for example, changes that are being made to the cluster, and from detecting breaches, for example, instead of monitoring the Kubernetes audit log, we need to monitor the Git audit log on top of the the Kubernetes API server audit log. So if we understand the fact that we can perform operations on the cluster itself through Git, we need to make sure that our Git repos are actually extremely secured, because at the end of the day, if we are letting go on our Git repo, this means that someone can easily take over our cluster. So the first thing is, how can we ensure that Git users are not impersonating each other? We really need to have a mechanism to attribute changes to the user that actually performed those changes, and pretty much making sure that all the nice features, the auditability features that Git has inherently are not breaking. So one way of doing that is either enforcing GPG signed commits, making sure pretty much that all commits are signed, and also leveraging pre-receive hooks to validate that the commit message contains the right user that actually performs the operation itself. Anything that revolves around, and this is a generic pretty much security concern with every system that has an audit log, is there anyone that is able to tamper with the history or the audit log and the changes that are being made to a system? So history rewrites are something that is possible in Git using forced pushes. So essentially, this is something that we definitely want to make sure we are not allowing, and also backing up the repo would be another way to mitigate this risk or at least weakness that as far as Git goes. The second part is we need to make sure that any security features that we are implementing on Git, so for example, if you are building a cloud service that is SOC 2 compliance, we are all aware that, for example, we must have more than one code reviewer as part of the merge and commit into the master branch. So if there is anyone that required to kind of, or is able to disable those security features, transitively, we can pretty much see that we can get those mechanisms overridden, and essentially we end up with having the system being circumvented by the fact that we can pretty much push things into the cluster without, for example, a commit reviewer or anyone that is making sure that this is something that was either allowed or disallowed. And again, if someone disables the Git provider's audit log, we can pretty much lose track and attribution of operations made by users. So think about it from an attacker standpoint. Git becomes a prime attack for an attacker to actually either go after users, especially those with privileges that can do operations on Git, because this is kind of their way to pivot from the Git repo to the cluster itself, simply by pushing a resource into the cluster, into the Git repo itself, which transitively will be propagated into the cluster by the GitOps operator. So when it comes to synchronizing, that's the main operation that a GitOps agent or an operator is performing. This is something that runs as a highly privileged component inside the cluster. So you can see here an example of the RBAC permissions that Flux is typically installed into the cluster. So you can see all the best practices, and again, Flux by design is supposed to act as a cluster god. But the fact that Flux, for example, is able to perform any operation in the cluster puts this component at risk, or at least from a blast radius perspective. This is a component that is highly sensitive, that we want to make sure that we are monitoring it in every possible way. So taking a step back a little bit and capturing the notion of operators, which was coined by CoreOS. This is pretty much a software that captures those either manual or semi-manual human operations, pretty much capturing those into a software and making sure that this is kind of the operation that are automating tasks that we are doing inside the cluster. So for example, tasks like backup, upgrades, restore are typical operations that we can see with operators, and there are many operators out there that actually performs that. And these operators could either operate on a cluster-wide level. For example, if you want to have an operator that provisions an application into a namespace, then this is something that would have cluster-wide permissions. But operators can operate at the namespace level as well. And the fact that we are running operators, sometimes third-party operators inside our clusters, this is something that pretty much we are running a persistent component, like sometimes third-party, inside our cluster. We all remember that those highly privileged components in Helm 2, Tiller was one example of such component that was running with either namespace kind of god or cluster god permissions. That's definitely something that we want to avoid from a security standpoint and in general. And when we introduce Flux into the mix and providing him these kind of star permissions on everything, we need to make sure that this is something that we want to monitor. So one way of actually monitor, so this is kind of a situation of like who's watching the cat that was assigned to kind of watch the milk. And essentially, monitoring the Kubernetes audit log is something that can help us establish, for example, a profile of what resources or what namespaces, for example, Flux would normally access, even though, by design, it is running with God permissions. Effectively, or in reality, Flux will not operate on all the resources on all times. And systems that can monitor the API server audit log and build a runtime profile on how Flux works can detect a situation where someone breaches, for example, our Git repo, and create, for example, a new namespace that was never seen before inside our environments. So this is an example of where AI and components that actually profile the runtime behavior of the system from a permission standpoint can help us detect breaches that are actually going all the way back to users and our Git repo. And if we try to take a look on what GitOps agents, and again, this can be Flux, Argo, or anything of that sort, would look like, then we can definitely see that from a workload perspective, we have the developers that can create application repos. And again, this is something that is more of how do you want to structure your GitOps workflows. There are multiple ways of doing that. For example, you can map Git repo to a namespace inside the cluster. You can map branches into namespaces. And this is something that each and everyone considering to adopt GitOps really need to understand, like what exactly they would like to achieve as far as the workflows and interactions between the teams. And based on that, kind of project this working relations to the way you implement your GitOps workflows. So essentially, we can see that we have config repo that basically represents kind of a lot of configurations associated with the cluster, and we can see that the GitOps agent, the operator, monitors those Git repos as well as the image registries that represents the software that essentially are being built or changed by the developers. So when it comes to this workflow, we really want to make sure that we monitor all the moving parts, so we can monitor the Git repos and making sure, for example, the changes are going through code reviews. Nobody can impersonate to other users when it comes to those commits, so we can attribute changes, and our Flux or Argo agents can pick this up at the right time. And essentially, this is something that we can really implement using those hooks, and that's pretty much what we can cover as far as the operator from that perspective. And again, the fact that we have a component inside the cluster that can do everything is something of a concern. Now, when it comes to the runtime, like what exactly those components are performing. So you can see here an example, and this is something that I pulled from our runtime agents and how they monitor activities related to like network activities related to component like Flux. And you can pretty much see here that the egress, so this is something that again boils down to, we have a highly privileged component inside the cluster that we really want to monitor on every possible aspect. So we are monitoring Flux in this specific example, the API, the Kubernetes API server audit log to make sure that nothing kind of deviates from learned behavior of Flux. But on the network side of things and the runtime, we can see, for example, that Flux has a very wide range of egress connections that are pretty much related to the fact that if we have Flux monitoring container image registries for changes in order to propagate, new image version changes into the cluster, you can see that actually Flux can interact with many egress points outside the world. And again, this boils down to the trust boundaries and potential risks associated with Flux. This is something that if we wanted to segment, it becomes extremely hard with Flux. And specifically with Kubernetes network policies, it's impossible to leverage those network policies on egress traffic, pretty much because we are using here domain names, and these are not stable network locations. And again, the key thing here is that we really want to make sure that we have a really good handle on the egress path of Flux. So using, for example, private image registries and a well-defined set of image registries could reduce the amount of egress connections that we can see from Flux. Same goes with Git repository. We want to make sure that the domains that Flux interacts with are a very limited and well-known set that we can monitor and control potentially with actual network segmentation component. And again, the fact that Flux can run as a god inside the cluster represents something that imposes a real challenge as far as security risk and blast radius. So when it comes to progressive security, so what does it really mean, progressive security? So if we think about deployments as an element that is progressive, which means that we push something to the cluster, and then as a next step, or the progressive kind of steps being taken after that, is that we have the GitOps operator deploying or applying those changes into the cluster. We can see here an example of how we can leverage a lot of the automation that is built into Kubernetes in a meaningful way and a powerful way, I would say, to implement progressive security. So if we try to kind of track through the workflow, we have developers making changes to either the cluster repo or the code repo. We have two main synchronization events. The first one can be triggered by a change that applied to a Git repo. So this is something that pretty much creates a synchronization of the desired state as seen in the repo to the actual state inside the cluster, or a synchronization that happens by monitoring the container image registries. And the reaction or the synchronization operation made by, in this specific example, Flux, pretty much gives us a series of events that deploys or applies those changes to the Kubernetes API server. And we can see here, pretty much based on those RBAC permissions, that we are definitely kind of making changes to the cluster. So we do have write permissions, as we can see here. Now, what can really happen at this point in time is that we can really, at this point in time, scan the changes or scan the cluster, the configuration changes, and the resources that were applied into the environment itself by tools that actually translates or understands the resource configurations themselves. So even if we pass through admission controllers that represents kind of guardrails, in this case, features or capabilities, for example, that would like to check, for example, if a workload have network policies applied to it, is not something that we implement using admission controllers. So we really need to have a mechanism or a way here that we can leverage, for example, that a check that verifies that all the workloads in a certain namespace have network policies applied to them. And the basic notion here is that if something violates those assumptions or guardrails, we can export, and specifically Flux has a really nice integrations with Prometheus and Flagger that monitors the metrics, is that if we can export security findings as metrics to Prometheus, then using that or leveraging that, we can have Flagger scrape those metrics. And if those metrics drift or represent a drift, for example, if we have a counter that counts the number of critical findings on violations of checks we had inside the cluster, for example, ingress controller not using TLS, then at this point, Flagger can trigger a rollback. And again, think about Git. This is a simple mechanism where we are rolling back to the previous kind of version, tag, or commit hash that represented a healthy state of the cluster. And it gives us a really nice way to do progressive upgrades and deployments and applying security and making sure, for example, that the system kind of moves from one healthy state and secured into another healthy state and secured without breaking any assumption on the environment itself. So I think that this is really kind of to conclude, captures what I wanted to share with you about GitOps and security and everything in between. And again, Kubernetes security by itself is an extremely kind of complex topic, and there are a lot of aspects to that, from configuration to runtime security, all the way up to monitoring to the API audit log of the Kubernetes API server. And we really need to figure out how we weave all those security mechanisms that we built for our Kubernetes, and making sure that even if we are going the GitOps way, we can still leverage and implement a lot of those mechanisms. So with that in mind, I think that we can switch to questions.
Okay, all right, we've gotten some great questions in so far, but there's plenty of time. If you have a question for Gadi, please go ahead and use your GoToWebinar control panel. Let's just dive right on into the questions we do have. Okay, here's the first one. If GitOps is a push model, how is it compatible with Edge, which typically follows a pull model for massive scalability?
So when it comes to Edge computing, then this is something that really boils down to the fact that Edge is something that runs kind of outside your cloud core. And in terms of push, I would say that I wouldn't be running GitOps operator on the Edge cluster. Actually, the deployment mechanism as far as leveraging Edge compute is something that I would pretty much automate outside the context of Git operator. So essentially, I would definitely not place Flux or Argo on my Edge compute. I would definitely put it on my cloud core and make sure that the cloud core connects to Git and propagates the changes to the Edge components. And there are multiple ways of implementing Edge compute, some of them related to the fact that you are running actually the control plane of the Edge in your cloud core. So, but I would definitely say that GitOps is not something you want to run inside your Edge clusters for this matter.
All right, great. Next question here. What types of branching strategies are the usual ones you recommend when implementing GitOps, e.g. Git flow, feature mainline, or golden mainline branch, or just select to the context of the situation or repo?
So this is really a matter of adjusting the situation or the application being built to the both culture and application. So and I touched a little bit about that. So let's take an example. Let's say that we have a Kubernetes cluster that is hosting multiple applications. Each application is running in its own set of namespaces, or let's say each application is being hosted on a single namespace, which means that the team that develops the application would be working on their own Git repos, and they can do their own dance within the context of this repo. But essentially, when it comes to the target cluster, it will land in a single namespace. So that's one way of adjusting the practice to the culture. A different example is if we have a single application running on the cluster, and then we have multiple teams that are developing different components of the system, then this is something that can be worked out leveraging branches. So it really boils down to kind of Git workflows, culture, and the type of application that is running on the cluster itself.
Excellent. Okay, next question. What is doing the pipeline flow / process orchestration? Is this Git hooks or orchestrators like Jenkins and just using Git as a trigger repo?
So as far as, and this is something that is really kind of implementation specific, pretty much hooks are the way to kind of get the events to the GitOps operator. So whether this is Flux or anything else, and which means that you really need to have a way to kind of get those changes. And the normal way would be for the GitOps agent to kind of have a token, a developer token for this matter, that can get access to the Git repo. So nothing really calls from your Git provider to the cluster. All the traffic is egress traffic. And from that perspective, from a security standpoint, this is a very healthy practice. I mean, you don't want to have anything goes into your cluster, into your most sensitive workload inside the cluster.
Excellent. Okay. All right, guys, lots more time for questions. So if you have one for Gadi, please go ahead and use your GoToWebinar control panel. Our next question here, are there any cognitive insights shown in GitOps?
Cognitive, that's a good one. I would say this is kind of on the eyes of the beholder. I mean, I had seen this with customers. I mean, GitOps presumably, I would say, tries to cater for, you know, engineering productivity and velocity, and I've seen this failing miserably with some of the customers that I have been working with, where, for example, very simple tasks or implementing GitOps, like before you have all the application components running, could be something that slows down the engineering cycles in a bad way. So I would say this is something that, you know, it's really something that you know, it's a per case kind of situation. Not a definite answer.
Okay. All right, great. Next question then. Do we have to install an agent for GitOps and Kubernetes as you're showing in the diagram?
Yes, this is, I mean, again, I'm coming from the security side of the fence.
Mm-hmm.
I mean, normally you can describe developers as those that see the full half cup. I normally see that as the full half cup that someone wants to steal. So yes, you install a highly privileged agent into your cluster that basically performs all the heavy lifting of deploying and reconciling and you know, addressing any divergence and alerting. So yeah, that's definitely part of how GitOps implementations like Argo CD and Flux are working.
Okay, all right, great. Next question here, is GitOps an extension for Git, and does it support supports for build without Jenkins?
It's not extension to Git, it's just an integration. And the second part was, can you repeat the Jenkins part?
Right. Let's see. Does it support builds without Jenkins? I think that's what he's asking.
Yeah, yes. I mean, you can definitely use, I mean, GitOps is completely separate from your CI. So your CI can be one thing. And GitOps is, so think about GitOps as your CD side of the CI CD. So CI, you can use Jenkins, and then for deployment, you can definitely use other stuff. Just like maybe I can show that in the slide. It was this one where CI pushed to image registries and GitOps agent would fetch this from the registry.
Okay, great. Okay, next question here. Have you seen many examples or use cases of anyone using Ansible in their GitOps pipelines?
No, I have not. I have seen that with Terraform, plain like plain vanilla YAML files in Git, Helm charts, but I have not seen. But if you find one, definitely shoot me an email. I want to hear about that.
All right, great. Next question here, and I hope I'm not wearing you out with all these questions.
No, this is good.
So many questions, yeah. Okay, so what, okay, we already have DevOps as PaaS, platform as a service. How can we add GitOps to our PaaS?
First of all, you need to be, I'm assuming this is a question coming from the developer side of the house, is to be in a good relationship with your DevOps. and see if they want to have that implemented as part of the deployment pipelines and everything. Because at the end of the day, this is something that changes practices and workflows fundamentally. I mean, no more kube control apply, becomes git commit and git push. So that's definitely something that a culture thing.
Okay, great. All right, next question here. What are the mere tools that I need to have when I start using GitOps? So I guess the minimum tools.
So minimum tools would be either something like Argo CD, Flux, or for example, I really like D2IQ stuff, so I have a bias here. Dispatch, so that's definitely tools. And Jenkins X is kind of a remanifestation of Jenkins, completely different beast. All of them follow similar practices. I think that what you really want to have as far as your GitOps tools is to make sure that all the extra stuff, like beyond just deploying and reconciling, like making sure, for example, that you have the ability to plug in hooks, like something that, for example, and this is, for example, how Alcide integrates with GitOps, like a post-sync hook that you can do a security scan, or something like Weaveworks where you have something that's more. So you really need to make sure that the extras are part of the tool that you choose, because at the very core, they're all doing similar stuff.
Okay, all right, great. Let's see, next question here. Is the Argo CD cluster role safer than Flux?
No.
No.
Both of them are cluster gods.
Okay.
Which means that you really need to guard them, like Kubernetes API, server logs, runtime, whatever you can.
All right. Okay. All right, next question. What is the role of branch permissions?
So if you think about like the push type of model, it really boils down to like who's allowed to push something to the cluster, or when exactly we are performing an upgrade. So all of a sudden, when we are shifting to GitOps, all the security features that we have on Git represents kind of the permissions we allow or disallow when it comes to pushing or applying changes to the cluster. So branch permissions, for this perspective, is something that if you are working with kind of branches mapped to namespaces, then this is really something that boils down to whether you can implement those access controls you want to have on developers or not. So that's pretty much kind of the translation of branch permissions to Kubernetes permissions.
Okay, all right, great. I think we have, well, let's see, we've got 2 more questions here. There's still time, guys. If you have any last minute questions for Gadi, go ahead and use your GoToWebinar control panel. Let's see, okay, so I use OpenShift container platform. How can I integrate with Git or GitLab?
So with GitLab, it's straightforward. You do your GitLab pipelines. I am not sure that GitLab has kind of a GitOps type of thing. And as far as OpenShift, and this is something that kind of the spirit of OpenShift is secure by default. In order to deploy something that runs with God permissions, you really need to have your OpenShift administrators like literally open up the cluster to deploy this root component, because OpenShift by default will not be friendly for many good reasons, I would say, especially as a security person, to deploy that. So once you have GitOps agent like Argo or Flux deployed and configured into the cluster, then you can pretty much at this point integrate those workflows into the cluster based on the fact that your GitOps operator will perform those changes into the cluster. And again, bear in mind that you bought probably OpenShift for the many security features it has. and now you're kind of circumventing, in quotes, those features and allowing to deploy to the cluster from Git. So again, this is something that you want to ask yourself, like, whether you want to go this path.
Okay. All right, great. Okay, next question. We have the following workflow. Where can we integrate GitOps? It's Jira to the left, then GitLab, then Jenkins, then Black Duck, then Artifactory.
At the end.
At the end.
So all those components represents a lot of the stuff that happens in CI. So the source scanning and building the artifacts and putting them on Artifactory. And after all of those, you at some point want to deploy them into the cluster. So GitOps would be the last component. Again, think about GitOps as CD. It's equivalent.
All right then. Let's see. I think we have one more question, then I think we're going to close it out because like I said, I don't want to wear you out here. Okay, so is it possible to have agentless GitOps? Can it be implemented with the help of Ansible?
I would call agentless GitOps as normal CD. I mean, that's push pretty much. And I mean, I'll be honest here and say I'm more of a fan of the push. I have kind of, you know, I'm getting the chills when I see like cluster guard inside the system. This is something that, you know, a security kind of person definitely worried about. So I have a personal kind of affinity to, actually this is cool because like agentless GitOps represents pretty much kind of the traditional CD.
Okay. All right, great. Well, that is all the questions actually that have come in. So I do want to thank everybody who did submit questions. Lots of really good ones. So thanks so much. Really do appreciate it. Let's say, also want to remind the audience that today's event has been recorded. So if you missed any or all of today's event, or if you just want to watch it again, you'll have the opportunity to do so. We will be sending out an email after today's webinar that contains a link to access the webinar on demand. And we are going to be hosting the webinar on the devops.com website. So you can always go look for it there. Just go to devops.com/webinars and look in the on-demand section, and it should be right there waiting for you. I mentioned at the top of the hour that we'd be doing a drawing for two $50 Amazon gift cards. So without further ado, let's go ahead and get to that real quick before we close things out. Today's winners are Elvis M. Congratulations, Elvis. And Tim P. Congratulations, Tim. We'll be following up with you, both of you, offline via email to get your gift certificates over to you, your gift cards over to you. Gadi, great presentation. Thanks so much for your time. Appreciate it.
Thank you, and thanks everyone for joining me. Feel free to try Alcid Kubernetes Security. You got all the links in front of you, and shoot me a Twitter, PM, whatever. Thank you.
All right, great. Want to thank the audience also for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody. Stay safe.